Right now, millions of drivers are slowly destroying their tires, suspension, and brakes with a single number that someone told them years ago. That number is 32 PSI. Your mechanic probably said it. Your dad definitely repeated it. The internet treats it like gospel truth. But here's what nobody told you. That number didn't come from your car manufacturer. It came from tire shops in the 1970s who needed one pressure that worked good enough for most vehicles. Not perfect, not safe, just fast and convenient. Today I'm revealing why 32 pounds per square inch is silently damaging your vehicle and showing you exactly where to find the correct pressure that engineers actually calculated for your specific car. The origin. Where did 32 PSI actually come from? Before we talk about the damage, you need to understand where this myth started. Because once you know the origin, you'll never trust generic tire pressure advice again. In the 1970s and 1980s, tire shops needed a quick default pressure they could use on every car that rolled through their doors. Checking individual specifications took time. Time cost money. So mechanics settled on 32 pounds per square inch as a middle ground number that worked reasonably well for most passenger cars of that era. Those cars weighed around 2,500 to 3,000 pounds. They had simple suspensions. Their tires were narrow by modern standards. For those vehicles, 32 PSI was often close enough to correct that nobody noticed problems. But vehicles evolved dramatically while the advice stayed frozen in time. Modern SUVs weigh 4,500 to 6,000 pounds. Crossovers carry weight distributions completely different from sedans. Performance tires have entirely different pressure requirements than economy tires. Suspension systems became sophisticated enough that pressure differences of just 3 to 4 PSI create noticeable handling changes. The cars changed, the number didn't. And that's where the damage begins. The Sidewall Lie. Why that bold number is wrong. Here's where the confusion gets even worse. When drivers finally decide to check their tire pressure properly, they look at the tire sidewall. They see a bold number, usually 44 PSI or 51 PSI, and assume that must be the correct pressure to use. That assumption causes just as much damage as the 32 PSI myth, sometimes more. The number printed on your tire sidewall is the maximum pressure that tire can safely hold without structural failure. It's a safety limit, not a recommendation. It exists to protect the tire from exploding, not to optimize your vehicle's handling, braking, or fuel economy. Think of it like a speed limit sign. Seeing speed limit 70 doesn't mean you should drive 70 in a school zone. The context matters completely. Different tire brands with identical sizes can show completely different maximum pressures. One might display 44 PS, while another shows 51 PSI. Your car's requirements didn't change. Only the tire's maximum tolerance changed. Following sidewall numbers guarantees you're either overinflating or underinflating based on random tire selection rather than actual engineering. Consequence number 1, increased blowout and structural failure risk. Now let's talk about what actually happens inside your tires when pressure is wrong. This isn't just about comfort or tire life. It's about catastrophic failures that happen without warning. Tires are engineered to flex in very specific ways as they roll. When pressure is too low, the sidewalls bend excessively with every rotation. That excessive bending generates internal heat that accumulates faster than the tire can dissipate. Over thousands of rotations, that heat weakens the internal structure. Steel belts begin separating from rubber layers. The tire looks perfectly fine on the outside, while the structure fails progressively on the inside. This is exactly why blowouts often happen at highway speeds, weeks or months after the original pressure mistake. The damage accumulated invisibly until the structure couldn't hold anymore. Overinflation creates different but equally dangerous problems. The tire becomes rigid and loses its ability to absorb impacts. A pothole that a properly inflated tire would absorb instead transfers full force into the tire structure. Belts crack, cords snap. The damage happens instantly rather than gradually, but remains invisible until sudden failure. Neither scenario gives you warning. Both scenarios can cause loss of vehicle control at the worst possible moment. Consequence number 2, hidden suspension. Damage your tires are the first layer of your car's suspension system. They're supposed to absorb small bumps, road imperfections, and minor impacts before that energy ever reaches your shocks, struts, and control arms. When tire pressure is wrong, this protective layer fails. Overinflated tires become essentially rigid. Instead of cushioning road impacts, they transmit sharp forces directly into suspension components. Your shocks and struts work harder than engineers designed them to handle. Bushings compress under forces they weren't built for. Ball joints absorb impacts that should have been absorbed by tire flex. Over time, suspension components wear out prematurely. Drivers replace shocks at 40,000 miles that should have lasted 80,000 miles. They blame rough roads or manufacturing defects. The actual cause, wrong tire pressure, never gets diagnosed. Underinflated tires create different suspension stress. Excessive tire flex makes the suspension constantly fight for vehicle stability. Control arms experience continuous micro-movements. Mounting points fatigue faster. The vehicle develops vague handling that drivers attribute to getting old rather than tire pressure. The connection between tire pressure and suspension life almost never gets made. But mechanics see the pattern constantly in shops across the country. Consequence number 3, accelerated and uneven. Tire wear. Tires should wear evenly and gradually across their entire tread surface. When they don't, you're replacing expensive rubber far earlier than necessary, and wrong tire pressure is the most common cause. Underinflated tires carry weight improperly. The edges of the tread bear more load than the center. Sidewalls flex excessively, generating heat that accelerates rubber degradation. The outer edges wear down rapidly while the center tread remains relatively new. By the time you notice, the damage pattern is permanent. Overinflated tires create the opposite wear pattern. The center of the tread bulges outward and carries most of the vehicle weight. That center strip wears quickly while the edges remain practically new. The tire might have thousands of miles left in the edges, but needs replacement because the center is bald. Once uneven wear establishes itself, no amount of rotation corrects it. Alignment adjustments won't fix it. Balancing is irrelevant. The tire is damaged and replacement is the only solution. According to tire industry data, improper inflation is responsible for approximately 25% of premature tire replacements. At $150 to $300 per tire for quality rubber, wrong pressure costs real money that adds up invisibly over years of vehicle ownership. Consequence number 4, compromised braking and handling. Your car's ability to stop and turn depends entirely on the contact patch where rubber meets road. Wrong tire pressure changes that contact patch in ways that directly compromise safety. Overinflated tires reduce the contact patch size. Less rubber touching pavement means less grip available when you need to stop suddenly or turn sharply. Braking distances increase. Steering feels nervous and twitchy. Emergency maneuvers become less predictable because you're working with less traction than the engineers designed. Underinflated tires create an unstable contact patch. The tread squirms and flexes under braking instead of gripping consistently. Steering response becomes vague. The vehicle may feel floaty at highway speeds. Corner turn-in lacks precision. These symptoms develop so gradually that drivers adapt without realizing their car handles worse than it should. Testing by automotive safety organizations has shown that improper tire inflation can increase braking distances by 10 to 15% in emergency situations. At highway speeds, that translates to several car lengths of additional stopping distance. The difference between avoiding an accident and causing one. Your car's safety systems, ABS, stability control, traction control, all assume correct tire inflation. Wrong pressure degrades the effectiveness of every electronic safety system your car has. Consequence number 5, decreased fuel economy. This consequence doesn't create dramatic failures or safety risks, but it quietly drains money from your wallet every week without you ever connecting the cause. Your engine must overcome rolling resistance to move the vehicle forward. Tire pressure directly affects how much resistance your engine fights. Both overinflation and underinflation increase rolling resistance compared to properly inflated tires, though underinflation creates significantly more drag. Studies by the U.S. Department of Energy found that proper tire inflation improves fuel economy by approximately 0.6% for every 1 PSI tires are brought up to correct pressure. For tires running 5 PS slow, that's 3% worse fuel economy. roughly equivalent to paying an extra 12 cents per gallon at current fuel prices. Over a year of typical driving, that invisible inefficiency costs $100 to $200 in wasted fuel. Over 5 years of vehicle ownership, wrong tire pressure burns $500 to $1,000 in unnecessary fuel costs. You'll never see a warning light for this. You'll never feel the difference while driving. You'll just fill your tank more often and never understand exactly why. The truth ain't where to find your correct pressure. Here's the simple solution that's been hiding in plain sight since the day you bought your car. The correct tire pressure for your specific vehicle is printed on a sticker located inside your driver's door jamb. Open your driver's door and look at the door frame where it meets the body. That sticker contains everything you need. The door jamb sticker shows recommended pressure for front tires and rear tires separately. It accounts for your vehicle's specific weight distribution, suspension geometry, braking system, and load capacity. Engineers calculated these numbers based on extensive testing with your exact vehicle model. Front and rear pressures are often different, and that's intentional. Most vehicles carry engine weight in the front, creating different load requirements than the rear. SUVs and trucks designed for cargo may have higher rear pressure recommendations to support additional weight. The sticker also specifies cold tire pressure, meaning the pressure when tires haven't been driven on for at least 3 hours. This is critical because driving heats tires and increases pressure readings by 3 to 5 PSI. Checking pressure after driving gives you false readings that lead to incorrect inflation. Your door sticker is the final authority. Everything else is guesswork. Why front and rear pressures differ. Many drivers see different front and rear numbers on their door sticker and feel confused. Some assume it's a mistake. Others ignore the difference and inflate all 4 tires to the same number anyway. Both responses create problems. The front tires on most passenger vehicles carry more weight because that's where the engine sits. More weight requires slightly different pressure to maintain proper contact patch and handling characteristics. The rear tires carry less weight on most sedans and hatchbacks, so they need different pressure to balance the vehicle properly. Trucks and SUVs often show higher rear pressure because these vehicles are designed to carry cargo or tow trailers. The rear suspension expects additional weight that regular driving doesn't provide, so pressure recommendations account for this design intention. When you ignore these differences and inflate everything to the same number, whether 32 pounds per square inch or any other arbitrary figure, you create imbalanced handling. The car may feel unstable in corners. Braking may pull slightly to one side. Tire wear becomes uneven between front and rear axles. The engineers already did the math. Trust their calculations. Cold tire pressure, the timing that matters. Even if you find the correct pressure on your door sticker, checking at the wrong time gives you wrong readings. This is where most drivers make mistakes that undo their good intentions. Tire pressure increases as tires heat up. Driving just a few miles can add 3 to 5 PSI to your readings. Parking in direct sunlight affects pressure. Even ambient temperature changes throughout the day alter readings slightly. Cold tire pressure means measuring when the car has been parked for at least 3 hours and hasn't been driven more than a mile or 2. This gives you a consistent baseline that matches the conditions engineers used when calculating the door sticker recommendations. If you must check after driving, add 3 PSI to your target pressure to compensate for heat. Then verify with a cold reading later. But cold measurement is always more accurate. Morning before your first drive is the ideal time to check pressure. The car sat overnight, temperatures stabilize. Your reading will be accurate, and any adjustments you make will actually bring tires to correct pressure rather than compensating for temporary heat expansion. Seasonal pressure changes. Why perfect today becomes wrong tomorrow. Temperature affects tire pressure more than most drivers realize. The air inside your tires expands when hot and contracts when cold. This means pressure set perfectly in September may be dangerously wrong by December. The rule is straightforward. For every 10 degrees Fahrenheit temperature change, tire pressure changes approximately 1 PSI. When fall temperatures drop 30 degrees Fahrenheit from summer highs, your tires lose about 3 PSI without any leak or damage. A tire perfect at 36 PSI in August sits at 33 PSI by November. Winter is particularly risky. Cold morning temperatures drop pressure below safe levels. Drivers see the tire pressure warning light illuminate, assume the sensor is faulty because they just checked last month, and ignore it. That warning is accurate. The temperature genuinely reduced pressure enough to trigger the alert. Summer heat causes overinflation problems. Tires inflated correctly in spring can gain 5+ PSI from heat absorption when parked in direct sunlight. Combined with highway driving that adds more heat, pressures can reach levels that accelerate center tread wear and increase blowout risk. Check pressure monthly minimum and always when seasons change. The 30-second tire pressure reset. Here's the exact process to get your tires to correct pressure in under a minute. Do this monthly or whenever seasons change significantly. Step 1. Open your driver's door and locate the sticker on the door jamb. Note the recommended front PSI and rear PSI. They may be different numbers. Step 2. Check your tires when cold, ideally morning before driving. Use a quality digital gauge, not the old pencil-type gauges that lose accuracy over time. Step 3. Remove the valve cap and press the gauge firmly onto the valve stem until the reading stabilizes. Compare to your door sticker number. Step 4. If pressure is low, add air until reaching the recommended number exactly. If pressure is high, press the valve core briefly to release air, then recheck. Step 5. Repeat for all 4 tires using front pressure for front tires and rear pressure for rear tires. Step 6. Replace valve caps and verify your tire pressure monitoring system light is off after driving a short distance. This process takes 30 seconds per tire and protects your tires, suspension, brakes, and fuel economy simultaneously. Do it monthly without exception. When 32 PS, I might actually be correct. Here's where I need to be honest. For some vehicles, 32 PSI actually is the correct pressure, but only because that's what the door sticker specifies, not because it's a universal standard. Older compact cars like the Honda Civic from the early 2000s, the Toyota Corolla from the late 1990s, or the Mazda 3 from the early 2010s often show recommended pressures near 32 pounds per square inch on their door stickers. These vehicles were lighter, with smaller tires that genuinely perform best at those pressures. Even for these vehicles, the number comes from the door sticker specification, not from generic advice. If your 2003 Civic's door sticker says 32 PSI, then 32 PSI is correct for that vehicle. If your neighbor's 2024 Ford Explorer door sticker says 38 PSI front and 35 PSI rear, then 32 PSI is wrong for their vehicle. The door sticker is always the authority. The universal number is always wrong. 32 pounds per square inch isn't a universal truth. It's an outdated shortcut from an era when cars were simpler, lighter, and less sensitive to pressure variations. Modern vehicles need the specific pressures that engineers calculated and printed on your door sticker, not generic advice passed down from tire shops decades ago. Your correct pressure is hiding in plain sight. Check it, use it. Protect your tires, suspension, brakes, and wallet. Thank you sincerely for watching this entire video. Comment your vehicle and what pressure your door sticker recommends. I'm genuinely curious how many of you have been running 32 PSI on cars that need something completely different. That's not tire care, that's tire intelligence.